Hey Java programmers, let's talk about testing our code and look at some techniques to do that. Here are some excellent books on the subject if you'd like to know more. Testing code is a good way to make a living. You could get a job writing test code for a company to test your own code and to test other people's work. An entry-level position for people who plan to become programmers sometimes is quality assurance, where you're running tests written by the developers, evaluating the results, writing up reports. You might not be doing as much programming, more than just running scripts, but that's a way to get your foot in the door if you're trying to get started with a software development career. So keep an eye out for quality assurance jobs. They might not pay as much, but they're definitely a way to get started. We refer to the term regression testing. That means software has been modified. There were changes made to it, or it was written from scratch, and it may not work the way it used to. We may have added something from scratch to an existing system, and we may have broken something that used to work. In other words, the quality of the software has regressed. Therefore, we refer to that as regression testing. Almost invariably, when you add complexity to a system, you're going to break something. Software systems are so big and so complex, it's crucial that you have testing in place. Of course, you're going to do some testing at your desk before you release the product into the repo for everybody else to enjoy. And then once it gets in the repo, it still may not be available to the group until it's been subject to even more testing. Some basic testing theory or strategery. One of the things that we have that frustrates us when we deal with end users, and please don't let yourself fall into this category, is that when they experience a problem, they might report it somehow, but they're certainly not going to tell you how they created that problem. They might give you some simple hints like, I was doing this when it happened, but we need a much higher level of repeatability in the tests that we design and program. If you can't repeat a test using the same conditions, it's extremely difficult and frustrating to try to fix that problem. Tests should be easily interpreted. It should be clear to whoever runs that test, very clear, whether the test succeeded or failed. That quality assurance technician who runs that test knows very little about the entire system and even less about the software that goes in there. Therefore, if the test has to be interpreted, if there is subjective criteria rather than objective criteria, you're going to lose out and you're just wasting the time of the people running those tests. We test what we call boundary conditions, also called corner cases, meaning that what's the largest value, the smallest value, the worst case scenario that this software has to deal with. That's typically where things break, is at the edges. For example, if you wrote a method to compute prime numbers, you might test the number 1 because it is neither prime nor non-prime. You certainly test the number 2 because it is the only prime even number, and that's a special case. You might test negative numbers because negative numbers might not even fall into the category of prime or non-prime based on the math definition that you're using. Don't test your own code. We fall in love with our code. We adore our code. we think in our brain that our code works. We have some level of unconscious confidence in our code. Even if we don't say it out loud, we still think that our code is right. We stare at it and stare at it. We edit and edit and edit. And in our mind, it's like our baby. We want it to be right. Therefore, testing it tends to create gentle tests that don't stress the code, don't test boundary conditions, and are often incomplete because we're testing something that we have an emotional attachment to. And then do test your own code. Well, one reason you might test your own code is because you know it better than anybody else, and you know the code paths, and you know the corner conditions and the boundaries. So therefore, it might be an advantage for you to write some of those test cases. We have conflicting philosophies of testing then. Don't test your own code. Test your own code. Your take from this should be a developing opinion on what that means. If you're asked in a job interview, or if you're asked while you're standing in line at Chipotle, what do you think about testing your own code? Have an opinion. Have something to say about it. It's a great discussion point in a job interview, and it gets the ball rolling and gets you talking about technology. The concept of a unit test is a piece of code that tests specific units of a program. Now, a unit could be a method. It could be an entire class. It's typically something that's easily understood and removed from the system for the purposes of testing. Logically removed, not physically removed. And you may be charged with writing unit tests for units of the product that you're developing. The unit is a little bit vague. You'll get more specific definitions if you go to work doing something like this, but you can think of it as an individual method. Usually methods are the smallest unit of code that we care about because they have an entry point and an exit point, and they have a name. If we try to start testing parts of methods, testing becomes problematic because in order to get to part of a method, we have to go through other parts of the method. Therefore, generally, the smallest unit that we test is a method. And again, if the class is small enough, perhaps we're testing the entire class as a unit, but that's going to be a function of the group that you're working with. The phrase test coverage is a reference to all of the code paths that go through that unit. Remember, every time you add an if-else, you've doubled the number of code paths in a method. And if you take all the methods together that make up a complex system, you have millions of code paths. It is impossible to test all of them because every one of them doubles the number of tests that you'd have to write. If you've got 10 code paths through a method, that's 10 if-else expressions. That's 2 to the 10th different code paths. That's 1,000 different tests right there to test every code path. And that's only one test per path. Therefore, test coverage is a legitimate concern because we want to have some feel for how much of the code is being tested in relation to how much of the total code there is that might not be thoroughly tested. The concept of test-driven development, or TDD, is typically oriented towards methods. In other words, I'm going to give you a method to be tested. You're going to look at the method signature to see the inputs and outputs of that method, and then you're going to develop your tests. You relate to that method by the Java docs plus any other specifications provided about that method. You can see again the importance of Java docs. We look at those extensively to learn about how we might write tests for that method. The Java doc typically comes into existence before the code inside the method is even written. An empty method is called a stub. That means that there's enough there to compile, but there's no logic in that method. You can think of it as an empty method, but there may be a return statement in there simply to get it to compile. And we write stubs to provide enough logic to build the project and then start writing tests against it. And of course, all the tests should fail if the method is just a stub. We haven't put any logic into it yet. In test-driven development, sometimes, well, all the time because it's TDD, we write the test first or in parallel. So you're writing a method as part of a system, and I'm sitting across the way from you in another cubicle, and I'm writing all the tests for that method. And your method is considered correct and ready to be rolled out if it passes all of my tests. Your correctness of your code is driven by the results of the tests performed by my code. And think about which person you'd like to be. Do you want to be the person that's writing the production code? Or do you want to be the person that's writing the tests for that production code? Both jobs important. Both jobs have a place in our ecosystem. You could say that the jobs are different and require different temperaments. Are you the temperament that wants to write the tests? Are you in attack mode? Are you going to try to break the code that I'm writing? Or are you in production mode where you'd rather be writing code that goes into the repository and contributes to the functionality of a system? And you may very well be both. You may go back and forth. It's just something you need to give some thought to as to what kind of temperament you have. Every method that you write should have a side effect. I'm referring here to Java because there are programming languages where side effects are prohibited. If you're a student of computer languages, I encourage you to research that. The concept of a side effect and the theory of a language that does not produce any side effects. It's called functional programming. Not something we cover here. I've given you two examples of side effects in slide 7. In the first example, I have a method called setFoo that looks like a setter. We talked about getters and setters for our private properties in our classes. This setter accepts an argument and assigns the value of that argument to a class level variable. The side effect then is that a change is affected on a class level variable. The one line of code in the method is that side effect. Something happened outside of the method. We changed the value of something outside the method. That's a side effect. Now in medicine, side effects are generally bad. When you go to the doctor and she gives you a prescription, you might say, what are the side effects of this medication? I want to know. Are my ears going to turn red? Or are my fingernails going to grow wildly long overnight? Or what? And side effects have to be considered as good or bad when you're prescribing medication. Side effects in programming, in this type of programming, object-oriented, are desirable. If a method does not produce a side effect, it's considered to be worthless. It doesn't do anything. In the second example on the slide, the side effect is output. That method is called say hello. It looks reasonably named. The name is decent, say hello, because the behavior of the method is to print something to the console. In this case, hello world. So the side effect is desirable and expected and well understood, but it is, technically speaking, as far as the compiler goes, a side effect. If your methods don't have a side effect and don't return a value, they are considered non-functional. They don't have any place in the code. Think about that. If they compute something and then throw it away, if they instantiate a class and then throw it away at the end, if they create a bunch of local variables inside of the method, assign them values, and then leave the method, those variables get deallocated. So essentially nothing has happened except compute time and memory have been consumed. Those are non-functional pieces of code. That's a mistake in our world. When you think about testing, what do we not need to test? Is there a method or any methods at all in your project that are so small and so obvious and so easily understood that they don't need any test cases? Again, that's a philosophical discussion that you would have with the company where you work. I'm not going to sit here and tell you what methods are too small to fail, what methods are absolutely necessary to be tested. And there's a reference on the slide to a comment made many years ago by, I'm not going to say who, but they said that in particular General Motors was quote unquote too big to fail, meaning whatever General Motors needed to stay in business they should get, because if they failed, the cascading effect on the economy would be disastrous. And that has kind of become a meme these days, too big to fail. That doesn't apply to us. That's just a little bit of historical trivia. Another thing to think about and have an opinion on, as I touched on earlier, who writes the tests? Do you write your own tests? Do you test somebody else's code? Do you feel comfortable trying to break your own program? Think about how you view your code. Do you have this emotional attachment to it and you probably shouldn't be the one testing it? Same thing with applications. If you write an app, should you be the one that tests that app? Because I guarantee you that 99% of us are very gentle with our own apps. We do not want to see them break. First of all, because we don't want to be the one to fix it. And second of all, because it's emotionally damaging to see our little baby break. We don't want that to happen. Therefore, have opinions on these things. There's no right or wrong answer. There is only opinion and well-supported or poorly supported positions. And if it comes up, be ready to talk about it. Think about an anecdote where you had some code and you turned it in as an assignment because you thought it was right, but you didn't test it thoroughly. And then looking back, you realize the reason you may not have tested it thoroughly is because you are attached to that code. It means a lot to you emotionally, and you didn't try to break it hard enough. We mentioned TDD earlier, test-driven development. TDD implies that tests are written in parallel with or before the code and then applied to that code. On the other hand, should tests be written after the code is produced so that you can look at it and say, I see a way to break this code. I'm going to study it deeply. I'm going to take it home with me over the weekend, and while I'm standing in line at Qdoba, I will look at that code and try to figure out ways to break it. Which is better? Is one different than the other? Is there an advantage to one over the other? Have opinions on those things. If somebody gets your code to test, especially if they don't know you, they have no reason to be emotionally attached to that code. They will probably write better tests. At least they will write more objective tests. And they may write evil tests. They may be the kind of person that wants to see code break and that works hard to find faults in code. Let's look at Monster.com, one of my favorite job sites. I don't know why. Let's look for TDD. I'm looking for a search box. I think they're not responding today. Okay, this is one of those days where things don't work. Let's just try dice. This one's kind of working. Here we go. This one has a search bar. TDD, test-driven development. I won't even put in a zip code. This is a search that I'm doing as I record this video. There are 2,268 jobs that mention TDD. Here's one with TDD in the title. They want to hire you to write test code. There's another one. That one mentions Java and TDD. You can see it goes on and on and on. My point here is that there is a living to be made, or an entry point into a company writing code to test other people's work. We talked about boundary conditions. Software that you write is most likely to break at the edges, at the corner cases. Here's a method that we should all be familiar with. It's called isPrime. You send it an integer. It computes the primeness of that integer, returns a true if it's prime, a false if it's not prime. How do you test that? What are good boundary conditions for testing this method? If I presented you with this and said, okay, your job is to write the test code, you might think, okay, 1 is neither prime nor prime. Let's put that in there and see if it crashes. 2 is prime, but it's even. It's the only even number that's prime. Let's put that in there and see if it crashes. What's a really, really big number? What's the largest number that will fit into an integer? That's a good test. What's the smallest number that will fit into an integer? That's a good test. There's 4 boundary conditions right there. How about 0? That's a good test. If I just tested 5 and 6, 5 is prime, 6 is non-prime, that wouldn't be a very good test suite either, because that's only 2 tests and it's just 2, for lack of a better term, average numbers. Again, as a tester, your responsibility is to think about how to break that code, and usually it breaks at the boundary conditions. We will use a testing framework called JUnit. A framework is a set of classes to accomplish something. There is a framework to connect to databases. There's a framework to create GUIs. There's multiple frameworks to create GUIs. There's a framework to do statistics, probably multiple statistic frameworks. And if you are in a job interview, they may say to you, have you done any unit testing? Your answer would be yes, because you're taking this course. And the next question would be, what framework did you use? The answer is JUnit. JUnit is an industry standard for Java unit testing. It's currently in version 5, and so it's rather mature. If I go back to DICE again and I search for JUnit, I get 1,234 jobs, which actually seems low, but you can see that JUnit expertise is in demand. I'll just drill down on the very first one. It says JUnit in the title. You don't even have to go to the job description or the requirements. It's literally in the title of that job. Therefore, learning to use JUnit is a good tool, is a good thing to do. We already talked about employers. When I made this slide, Monster.com was functional. It found 5,400, almost 5,500 jobs that mentioned JUnit. I don't know what's wrong with Monster today, but oh well. Maybe everybody is searching for jobs today. JUnit is open source. The framework can be downloaded. It doesn't have to be an Eclipse-centric tool. If you're using another IDE like JetBrains or NetBeans, you can also use JUnit. So you're not limiting yourself to Eclipse when you learn this. We're not going to go to GitHub and download this. We're not interested in the source code for the framework. I just wanted to show you the kind of ecosystem we live in has a lot of stuff that's open source. The entire Eclipse IDE is open source as well. JUnit is part of Eclipse. Now that's a very vague term. The framework itself, the Java classes that run the unit tests, are different than the interface provided by Eclipse. There's some interplay between the two. Eclipse knows how to talk to JUnit classes because Eclipse has been around long enough that they built in the support. So again, Eclipse lets you do things conveniently with the framework, but you don't have to use Eclipse. You can use other tools as well, like NetBrains or JetBrains, or I can't think of any other ones right now. We're going to create a project, and then we're going to add test cases through the Eclipse interface. And you'll see that it's pretty straightforward to do that. I'm going to skip ahead, and I'm going to have you go to slide 23, grab the code off of slide 23. This will be the object of our testing. We'll build a project around this, so you just don't have to type in all these things. Back to Eclipse. I'll create a new project called Unit Testing. Whoops, that's not what I want. Got ahead of myself there. General Java project. So the project is the same that we've done before. The project name will be Unit Testing. Looks like I got really ambitious today and put a space in my project name. I'm going to stop myself. And I'm not going to put a space in there. You can, I'm just not going to do it. Let's close up all these other things. In our unit testing project, let's create a new class. Call it fish, because that is what we copied off the slide, the fish class. Now I am not picking a main. There will be no entry point in this project. And that's crucial. Keep that in mind. There is no entry point in this project. It is just the fish class. The reason we've had entry points in the past is because we needed to run our projects. But we're not going to run this as a regular Eclipse project. We're going to run it as a unit testing project. So we don't need a main because the JUnit framework will provide the main. And this mirrors real-world behavior too, because if you're developing a class for a repo, for a group project, the main's going to come from somebody else 99% of the time. So why even create a main? Why not just let JUnit do the entry point logic for you? Click Finish. Paste in the code off the slide. I just overwrote everything. And I didn't create a package, but I did that on purpose. I'm going to let Eclipse move my source code into that package. That will require it to create the package, but Eclipse is happy to do that. So if you look over on the left in the Project Explorer, you can see that unit testing project has no explicit packages. It just has the default package. When I click on this quick fix, it's going to get a package. Here we go. Kaboom. It got a package. It moved my code into that package, and we are good to go. I hope and pray at this point that you look at this code and it gives you a stomach ache because it is not formatted very well. And I think it's Control-Shift-R, right? No, Control-Shift-F. There we go. Control-Shift-F automatically reformats the code. That makes your stomach feel a little bit better. You should still be nauseated though because there are no Java docs here and there is no comment header at the top. I'm going to skip those just for the sake of brevity, but you know the rules. You know that we document our code and you know that we write Java docs for all methods except the main method, which we don't have here. And let me go back to slide 19. At this point, we have something we need to test, the fish class. So we have decided that unit tests are applicable to that class. Now, when we break it down, we're probably going to write unit tests for the methods in that class. You can think of it that way if you like. If you want to think of it as testing the entire class, we're actually testing the individual methods in that class. So let's add a unit test case back to Eclipse. Right-click on the project and say New, and then say Other, and then somewhere in here, whoops, if we type in the word unit, we don't find it. What if we type in JUnit? There it is. Just the word unit wasn't enough. The search feature in that wizard dialog isn't very good. You have to start with JUnit, not just unit. We will do a JUnit test case. Click Next. Now, you can regress to earlier versions of JUnit. Unless you're told to do that, there's no need to. Just take New JUnit Jupyter Test. Depending on what version of Eclipse you have, when you're watching this video, you may see a slightly different dialog here. You can put your test case in the same package. Now, most people have a fit if you do that. Let's call this the test. Let's call this unit test package. And let's give it a name. We'll call this unit test. Give great care to the names. Remember, you're seeing a proliferation of names of things. So give careful care to naming and be aware that in a year you're going to regret every name that you pick because your naming style changes as you learn more about what you're doing. Don't beat yourself up over the name. Just make your best attempt to name things descriptively and consistently. At the bottom, it wants to know what class you're going to test. We could be testing the entire class. We could be just testing methods in that class. But either way, you've got to provide the class. Now look at the very top of the dialog. It says class under test does not exist in current project. Okay? What you have to do is qualify that with the package name, because the package where you're putting the test case is not the same package where the class under test lives. This is a good thing to keep them separate in different packages, because the class under test should be able to survive and thrive and perform without the presence of the test cases. Therefore, putting them in the same package is problematic, because if you try to delete the test cases, you may accidentally delete something that you need. At this point, if you've got everything filled in, you can click Finish. The very first time you do this in a project, Eclipse realizes it knows about JUnit, but your project doesn't know about JUnit. Therefore, you have to tell Eclipse it's okay to add that to the build path. So it's adding a reference to part of the framework, the JUnit framework, into your project. If you say not now, your project will not build. If you say open the build property page, you've got to do it yourself. I would not suggest that right now. Click OK. Observe that there is now another package in your project called unit test package, and there is a unit test.java in that package. Should you start documenting this like crazy? Yes, as you go along you should, because people will look at this. The test code is just as important as the production code, and it may be harder to even to understand, so documentation is still at a premium here. Back to the slides. I skipped up to slide 22 because I already covered the material in those intervening slides. And let's take a step back. We have a fish class. That class was written based on a spec. I'm using the term spec in a general sense. It could have been a meeting that you had with your peers. It could have been an email that you received. It could have been a formal specification provided to you by a systems analyst. It doesn't matter at this point where this spec, quote unquote, came from. It's also spelled wrong. Whatever this spec, whatever form it takes, somewhere in the spec it says when you create a fish, the name of the fish cannot be blank. It's logically incorrect to have a fish object swimming around in a program without a name. That's an arbitrary decision that somebody made up the chain. Now it's your job to write a test case to make sure that that doesn't happen. Here's the test case. Here's the code we're testing. We've already pasted this into our program. It has a constructor. The constructor right away breaks the spec because it assigns a blank string to the name of the fish. Spec violated right there. Alarms go off. Fire suppression goes into play. The door's locked down. Something happened and our specification is broken. And then there's a getter and a setter for that private property, the name of the fish. I'm sorry, the getter and the setter are here, my fault. And then there is a constructor that takes the name of a fish and stores that into the class level variable called name. We have two constructors. One takes an argument and the other one does not take an argument. We've overloaded the constructors for this fish class. Perfectly fine to do that, but this particular constructor breaks the specification. Syntactically, we're correct. Logically, we are incorrect. So I cobbled together 3 test cases, and we'll talk about these test cases together. Some of this stuff we can ignore. What I want you to do then is just copy the 3 test cases. You can leave the rest of it on the slide. We don't need it. But if we copy those 3 test cases, we can paste those into our Eclipse code and not have to type in all that logic. All right, copy just the 3 methods, each of which has an @test preceding it. That's called a decoration. That tells the framework about that. That tells the JUnit framework we're about to create a test. Go back to Eclipse. Overwrite the test case provided for you by Eclipse. You don't need that anymore. You can just delete it. Paste in those 3 test cases. Take a close look. We have an immediate problem because it doesn't know what a fish is. This test class is in a different package from the fish class. Eclipse knows where it can find a fish class. The quick fix is import fish from the fish package. Eclipse knows where it is. Eclipse says, hey, I found that for you. This is probably what you want. It's in the same project. It's right next door. Maybe I should just import that for you. There you go. Take that first fix. The errors go away because now it knows that the fish class can be found in the fish package. It knows what that data type is. Let's look at the 3 test cases. The first test case is the one that's going to fail. And what we're doing is creating a new fish object. And we're taking the default constructor. If you look back at the fish class, the default constructor assigns a blank string to the name of the fish, violating the specification. That's fine, but the next line of code is an assertion statement, and the assertion statement must assert to true, or the test is considered a failure. What that means is whatever you put in these parentheses has to be logically true. And that's where your creativity comes in. That's where you figure out how to determine whether or not the fish has a name. In this case, I'm calling getName. I'm computing the length of what is returned by getName. If that length is not equal to 0, then that is a true condition and the assert succeeds. If the assert fails because the name is 0 length, then that test will fail. Short and sweet, all your test cases have to have some kind of assert logic in them. In the second test, got a little comment here, test if the name is stored correctly when we call setName. In this case, then I'm testing setName. I'm creating a new fish. I am doing a setName to give it the name Perch, a wonderful fish, swims around all happy. And then my assertion is whatever is returned by getName has to be Perch. If it stored it as pouch or bass or blank, the assertion failed because the getName method would not return perch. When the assertion fails, that test case fails. The third test, I realized that since there is a constructor written to accept a fish name, I better test that constructor, making sure that it stored the name correctly. Same logic. Create a fish object, use the explicit constructor that takes the name of the fish as an argument, and then do the same assert as the previous test to make sure that it actually stored the name correctly. This is the process that I go through writing test cases. And if this appeals to you, this might be a kind of development strategy that you want to get into. Maybe you want to pursue a path as a tester, a testing programmer, or whatever the title is. Well, we've built 3 test cases. We've worked really hard. Let's see the fruit of our labors. How do you run this thing? Here's the results of the run. I'm building the tension before I actually show you how to do it. When you run it, it brings up a whole new interface, the JUnit pane. And in the JUnit pane, it will tell you which tests passed and which tests failed. It will also annotate them in green if they passed. So a visual review of all the tests easily shows you which ones succeeded and which ones failed. As a quality assurance tester, as someone who works for the company and runs these tests all day long, it's very easy for you to tell if they all worked or if they didn't. You can also look at the count. It tells you that there was 1 failure. It ran 3 tests, they all completed, and 1 of them failed. And then you write up your report, you send an email, you set off an alarm, you shoot out a text message. Whoever wrote this code had better come in and fix it because the test failed. Now, how do you run the test? Well, let's say we don't know how. We've gotten this far. We created a test. We used the framework. How do we run it? I'm not really sure. Do I click run? Well, I don't see anything there. Not off the top of my head. Do I right click on it? I don't see anything there. Do I right click on the project? Run as? Look at that. With a little bit of investigation, I was able to figure out one way at least to run the test cases. I can run it as a Java app. That's going to fail. There ain't no main. Remember, we never created a main. That way the app, there's no way it can run as an app. But we know it can run as a unit test. Let's click on that. Mine's at the bottom. There he is, right there. That little tab shows up. If you look at my slide, the tab, the JUnit tab, appeared over on the left in the same pane as the Package Explorer. In the configuration I'm running today, it showed up at the bottom in the pane with the console tab. You can move it around if you like, depending on what your preference is. I kind of like having it at the bottom. But I can see that the very first test failed because it's got that little X next to it and it's not green. The code ran, but when this assertion tried to see if that logical expression was true, it was false and it could not make that assertion. In the next slide, I mention that there are a whole bunch of assert methods. You can assert 2 things to be equal. You can assert that something is true. I'm actually using assert true in my code. but I'm using a different version of it just called assert. You can read about that and see more of those at different places on the internet. Here's another test we might add. We can create a fish with a name. We know that works. And then we can write a little bit of logic in the same test to erase that name. I can try to circumvent the spec, create a fish legitimately with a legitimate name, and then try to change that name to blank. Looking at the code that we've used, we know that's going to fail. We know that's a test case that will violate the spec because we can call the setter, we can pass the setter a blank string, and the setter doesn't care. It's going to use that blank string as the new name of the fish. So that would be another one that would fail. And I would encourage you to write that test case. You could tuck it in right here underneath the other test cases. Whoops. You could copy paste existing code, modify it just a tiny bit to create that test scenario. You would see that you can create a test case that will violate the spec, and that should fail. That test case should fail when the fish class runs as is. Another test case, can I just pass a blank fish name to the constructor when I create a brand new fish? Looking at the code, yes, I can, because the constructor that takes a fish name does not do any kind of validation check on that name. Therefore, it will store a blank name. That's a violation of the spec. By codifying all of these test cases into a JUnit test package, we can run these tests today, and then after our developer fixes that fish class, we can run those tests again to make sure very easily that they fixed all the problems. You can see it's a big advantage to store all of these test cases in one little location and use the JUnit framework to run them over and over and over. Another philosophy that you're going to run into is, where do you put the test cases? Now, in my example, I put them in a separate package in the same project. I created a package called Unit Test Package. I put my JUnit code in there. Now, there are people who are violently opposed to this, strongly opposed to this. They feel that unit testing should be in a completely different project, completely separate from the production code. Again, have an opinion on that. Think about the ramifications of that. Is that good or bad? Is it okay to keep it where it is? Is it better to move it to a separate project and have it test things in the production project? Think about that. If you'd like to know more, again, you can go to the documentation for JUnit. I don't know if a JUnit 6 is on the horizon. There may be. I don't know if JUnit 5 needs improvement, if it has any bugs in it. I have a feeling it's pretty mature, having gone through 5 releases, but you never know. If you look in the wiki, you might see that they're asking for contributions to a new version of JUnit, and you might be someone who can jump in there and help with that project. So thanks for watching. I hope this was interesting. Go back and write some test cases. I gave you 2 suggested test cases to write. Both of them should fail. And get some experience hands-on working with the JUnit framework so you can say that, yeah, I have written test cases and I understand the philosophy of using a framework to write unit tests. Thank you very much.